In this problem, they're giving us temperature and rate constant data for a reaction that was carried out at several different temperatures. They're asking us to produce a graph. I don't need you to turn this in on paper, but I do suggest that you use your graphing calculator to produce the graph. First things first, before we get into the exact calculator menus to use, the Arrhenius equation relates the rate constant to temperature in a logarithmic equation, which is especially useful for us. This equation is written in the format y equals mx plus b. Notice that the slope of this straight line is negative activation energy over the gas law constant R. So as long as you're producing a graph where the y-axis variable is the natural log of the rate constant K, and the x-axis variable is 1 over temperature, as stated in degrees Kelvin, then you'll get a straight line whose slope is negative activation energy over the gas constant R, which is 8.3145 joules per moles times degrees Kelvin. Knowing that, then we can take the data that they gave us and manipulate it a little bit. You can do this in your calculator. In fact, I would suggest going to Stat, Edit, and then manually enter the temperature data and the rate constant data. And whichever column you entered the temperature in, set another column equal to the inverse of that temperature. So for example, let's say that I entered temperature data in the column L1 under my Stat Edit menu, and I entered the rate constant data under L2, and then I highlighted L3, and you have to go up to L3 and hit enter in order to get the cursor to flash there, and I want that to be equal to the inverse of temperature. Well, I wrote 1 over L2 by hitting second and the number 2, and then hit enter, and it populated the L3 column for me. Similarly, I went over to column 4, L4, and said, okay, I want that to be the natural log of the rate constant K. So what I did was I highlighted L4 and hit enter so that there was a flashing cursor there. And I typed in natural log and natural log of L2, L2 for that one. Students, earlier I said natural log of L2, it's actually, or 1 over L2, it's actually 1 over L1, 1 over temperature. But in L4 I want that to be the natural log of L2 because we had entered the rate constant data under L2. And then hit enter and it populates L4 for you. Then, once you've got that data, you could zoom stat to view the data and verify that it's a straight line with a negative slope. Or you could just go straight to Stat Calc and hit the linreg option. That is linear regression, and they're going to give it to you in the format ax plus b. On my calculator screen, once I select that option, it goes linreg, it says ax plus b, and then they want you to type in which two variables you want plotted against each other so that it can pull that linear regression data. In my case, I typed in L3 for 1 over temperature. I want that to be the x-axis variable, and L4 for the y-axis data, and I want that to be after the comma. So linreg ax plus b, and then I typed in L3 comma L4, hit enter, and when I do that, we're particularly interested in the slope, and in my case that worked out to be negative 1,436 from the calculator screen. Once you've got the slope, then we can set that equal to negative activation energy over R, which is 8.3145 joules per mole times degrees Kelvin. And if you type or multiply negative 1436 by 8.3145, the activation energy, the negative signs cancel out, and we get 11,939 joules is the unit it will come out in. If you look at the WebAssign answer, the unit for the answer there, they want kilojoules rather than joules. And the per mole bit, don't worry, that means the unit we came up with was actually joules. Sometimes it's written as joules per mole, but it means the same thing. It's joules per moles of the species that react in the equation based on the coefficients in the balanced equation. So if we need to convert joules into kilojoules, we divide by 1,000. So that's 11.9, rounding to 3 significant figures, kilojoules per mole. Now the other way to do this, if you didn't want to use your graphing calculator, you could take the very topmost data point from the data table and the lowest data point from the data table, manually take 1 divided by the temperature in Kelvin, and manually take the natural log of the rate constant. Take delta y over delta x. And in that case, you get an answer that's very similar. After multiplying by 8.3145, I got 12.0 kilojoules per mole rather than 11.9. So if you do this manually or on your graphing calculator, you'll get something in close agreement. So either way is fine.